lagi dengan syllabus the next chapter lah, capacity and level of service for highway segments, akan dibentangkan oleh kumpulan 7 dan kumpulan 8. Okey, sebelum tu saya ada dua pengumuman. Yang pertama tentang makmal. Untuk petani kita akan sambung lagi dengan dengan partial test, partial test. Nanti kamu tengoklah dalam tu ada satu kita partial test, and then data pun saya dah masukkan dalam ni lah, dalam kamu punya WhatsApp group. Terima kasih kepada Cinjia Liang kerana bantu saya. Saya pun tak sure dulu macam mana data tak ada, macam mana boleh buat eksperimen tu. So nanti untuk hari ni kita fokus on partial test stability and flow, dan nanti kamu akan buat dalam report lah. And then yang keduanya, kita akan pada hari Jumaat ni 25 Jun 2021 kita ada seminar siri webinar alumni, iaitu oleh Encik Muhammad Faizal bin Nuruddin. Encik Muhammad Faizal ni adalah satu batch dulu dengan Dr. Norinah RAHMAD. He has a quite extensive of experience dalam reconstruction particularly. So untuk hari Jumaat ni dia akan buat satu sharing session berkenaan dengan pembinaan Lebuhraya pesisiran pantai barat belantara ke Lebuhraya. Ini kita akan dengar lah. Tapi I think for this seminar dia akan cover the whole including structure, geotechnics and also reconstruction. Tapi kalau saya stress is given more on the geotechnical part lah. Tak apalah. So kita akan tengoklah tentang pembinaan jalan raya ni. Alright, so kalau tak ada apa-apa, can we start dengan first group to presentation ni?
Boleh, Doktor.
Boleh. Lim
Ya.
Okay. Please.
Doktor boleh nampak slide ke?
Okay. Clear. Right.
Okay, sekarang saya start. Good morning, everyone. We are from Group 7. Today we're going to present about capacity and level of service for highway segment. Now I'm going to pass to my group member to start our presentation.
For highway segment, we have two levels of analysis, which are operational level analysis and planning level analysis. Class 1 is two-lane highways that function as primary daily commuter route other arterial highway. Class 2 is two-lane highways where the expectation of motorists' travel speeds will be lower than for Class 1 route. The average trip length on Class 2 highways are shorter than on Class 1 highways. Next. At operational level analysis, level of service LOS is determined based on existing or further traffic condition and specific roadway characteristic. At planning level analysis, operational procedures are followed, but with the estimation of HCM default values and or local default values. Next. There are two measures used to describe the service quality of a two-lane highways, which is % time spent following another vehicle PTSF and average travel speed ATS. PTSF is the average % of time that vehicles are traveling behind slower vehicles. It is a measure of the quality of service provided by the highway. ATS is the space mean speed of vehicles in the traffic stream. It is a measure of the degree in which the highway serves its function of providing efficient mobility. Next. Capacity of a two-lane highway is 1,700 passenger cars per hour. For extended segments, capacity will not exceed the total of 3,200, and for short section, capacity will be about 3,200 to 3,400. Level of service is the performance of a highway at traffic volumes less than capacity. LS of Class 1 is based on PTSF and ATS, and LS for Class 2 is based on PTSF. LS criteria are applied to travel during the peak 15 minutes of travel and on highway segments of significant length. The highest level is A and the lowest is F. Next.
Okay, thank you, Basil. And I'm going to continue with the relationship of speed flow and percentage time spent following with the two-way flow rate. For the graph of average travel speed versus two-way flow rate, it shows that when the number of vehicles increase, which is the two-way flow rate increase, it will reduce the average travel speed as shown in the graph. For the graph of percentage time spent following versus two-way flow rate, it shows that when the number of vehicles increase, which is the two-way flow rate, it increases the percentage time spent behind the slower vehicles. Next slide, please. So now I'm going to talk about the characteristic of every level of service from A to F. Level service of A, the highest quality service that can be achieved. Motorists are able to travel at their desired speed. The need for passing other vehicles is below the capacity for passing, and few patterns of 3 or more cars are observed. Class 1 highway average travel speed, which is ATS, is 88 km per hour or greater. For the PTSS, F, which is the average percentage of time that vehicles are traveling behind a slow vehicle, is 40% of the time. And then the maximum service flow rate two-way under base condition is 490. Next slide. Then level service of B. If vehicles are to maintain the desired speeds, the demand for passing other vehicles increase significantly. Class 1 highway average travel speed ATS are 80 to 88 km per hour. PTSF travel delays are between 35% to 50% of the time. And then the maximum service flow rate under base condition is 780. Next slide. And then level service of C. Further increase in flow below levels of service B range result in a noticeable increase in the formation of platons of size of platons. Passing opportunity are severely decreased. Class 1 highway average travel speed ATS are 72 to 80 km per hour. PTSF travel delays are between 50% to 65% of the time. Class 2 highway maximum delay PTSF is 55 to 70%, and then the maximum service flow rate under base condition is 1,190. Next slide. Then level service of D. Flow is unstable and passing maneuver are difficult. The number of passing opportunity is approaching zero. Class 1 highway average travel speed ATS are 64 to 72 km per hour. PTSF travel delays are between 65% to 80% of the time. Class 2 highway maximum delay PTSF is 70 to 85%, and then the maximum service flow rate under base condition 30. Next. And then now we're going to continue with level service of E. The number for passing opportunity is virtually impossible. Patterns are longer and more frequently. Class 1 highway average travel speed ATS are 40 miles per hour or less. PTSF travel delays is greater than 80% of the time. Class 2 highway maximum delay PTSF is greater than 85%. And then last but not least, maximum service flow rate under base condition is 2,300 Next. Then level service of F. Traffic is congested with demand existing capacity and volume are lower than capacity and speed are variable. Next slide. So now I'm going to go through one example with all of you, which is example 9.1. So now I'm going to read through the question first. The following values of PTSF and ATS has been determined based on the analysis of 4 roadway segments. Methods for performing the analysis are described later in this chapter. So determine the LS if the roadway segments are A, class A, and B, class 2. So I'm going to go through the example for class 1 only. So for the question 1, it shows that segment 1 PTSF is 36% and ATS is 87%. Yongliang, can you please open slide 8 for me? Thank you.
Slide 8.
Yes. Oh yes, is 54%, and then the ATS is 96 km per hour. So Yongliang, please open slide 9, please. Okay. So as this slide shows that the average travel speed ATS are 72 to 80 km per hour, and then the PTSF is between 50% to 65%. So levels of service C will be the answer of that question. So you can go and do the previous. Okay, so the answer shows that the segment 2 is level of service type C. So if you go to this our slide, you can actually answer below. So this is all for me. So I'm going to pass to another member to continue our presentation. Thank you.
I would like to present about the procedure for determining level of service. They have 2 ways to determine the level of service. First is two-way segments located in levels or rolling terrains. Grades are 1 to 2% and heavy vehicle maintain the same speed as passenger car. The second is direction segment, for which the LOS is determined for traffic in a single direction. Any segment can be analyzed as a direction segment. The procedure is used to analyze extended direction segment. Specific upgrades or downgrades defined as 2-lane highways located in mountainous terrain and with grades that exceed 3% in segments exceeding lengths of 0.6 meters and passing lanes for relative short uniform segments. And next slide. Okay, this is the two-way segment. The analysis of two-lane routes or two-way segments is usually performed on extended lengths when the segment length is at least 2.2 miles and the segment is located in level or rolling terrain. The level terrain segment contains flat grades of 2% or less. Heavy vehicles are able to maintain same speed as passenger car throughout the segment. Rolling terrain segment contains short or medium length grades of 4% or less. Heavy truck speeds are slower than passenger car but are not at crawl speed. If grade exceeds 4%, the two-way segment procedure cannot be used but must be analyzed using the specific grade procedure for direction segments. Next. Okay, here is the formula on how to calculate the two-way segment. The PTSF equals to BPTSF plus FD or the FD over MP. So what is FD over MP is adjustment in PTSF to account for the combined effect of 1% of direction distribution of traffic and 2% of non-passing zone. Okay, where PTSF the base time the base percent time spent following for both direction and is computed using the equation 9.2. BPTSF equals to 100. 1 times with 1 minus exponent of 0.000879 VP. VP is a passenger car equivalent flow rate for the peak 15 periods in computed using equation 9.3. Next. Okay, so what we share is VP can be found using the equation 9.3, which V over PHF times with FG times with FHV. So V is the demand volume for entire peak hour, PHF is a peak hour factor, and F is the grade adjust factor for level or rolling terrains. FHV is the adjustment factor to account for heavy vehicles in the traffic stream and is computed using equation 9.4. So the next equation 9.4. So this is the equation 9.4. P and PR is the decimal portion of trucks and bus, and RVS in the traffic stream. For example, if there are 22% trucks in traffic stream, then PT is equal to 0.22. ET and ER, the passengers car equivalent for trucks and RVs, respective value are provided in table 9.5. Next. Okay, since the value of ET and RT are functions of two-way flow rates in PC power, an interactive process is required in which a trial value of VP is based on the PHF only. Then a new value of VP is computed using appropriate values and ET and ER. If the second value of VP is within the range used in to determine trucks and RV equivalents, the computer value is correct. If not, a second iteration is required using the next higher range of flow rate. Next.
Okay, now we're going to discuss about how to calculate the value of ATS, average travel speed, for two-way segment. The average travel speed ATS equal to FFS minus 0.0125 times VP minus FNP. Okay, first of all, we need to know how to calculate the FFS. FFS is the free flow speed. There are two ways to calculate it. One is for the have the field data. One is for unknown field data. For known field data, there are two cases. For measurement at volume smaller than or equal or bigger than 200 passengers car per hours, we're going to use the following equation. FFS equal to SFM plus 0.01249 times VF over FHV. The FHV is discussed previously in the previous slide. Okay, for the unknown data, field data equation, we're going to use the FFS equal to BFFS minus FLS minus FA. The FLS is the adjustment for length and shoulder width. For FA is the adjustment for number of access point per mile. For the FLS, we're going to use the table 9.9 as shown in the right hand side, and for the FA, we're going to use the table 9.10. For the BFFS is the base free flow speed. Range is in the 72 to 104 kilonewton per hours. Now we're going to discuss about how example 3 on how to computing the value of average travel speed for a two-directional two-lane highways. Based on the equation, use the data provided in the example 9.2 to estimate the average travel speed. Assume the base free flow speed BFFS is the posted speed of 96 kilonewton per hour. The section length is 9.6 kilometer. Length width is 3.35 meter. Shoulder width is 1.2 meter, and there are 20 access point per kilometer. The step 1, we're going to find the FFS first. In order to calculate the ATS, we need to first find the free flow speed first. By using the previous slide show the equation. First, we can get the FLS equal to 2.7 kilonewton per hour, FA equal to 8.0 kilometer per hour, sorry. For BFFS equal to 96 kilometer per hour. Therefore, we can get the FFS equal to 85.3 kilometer per hour. Then we can substitute the value inside the ATS. But first of all, we need to know still have two unknowns, VP and FNP. For VP, we're going to use this formula. By substitute the data given, then we can get the VP equal to 1,827 passengers car per hour. And the following data given, we can get the FHV. By substitute it in the following equation, we can get the FHV equal to 0.931. Substitute all the value inside the ATS equation, we can get the ATS equal to 61.2 kilometer per hour. Now I'm going to discuss on how to calculate other traffic performance measure for two-lane highways. There are 4 addition measure. One is the first is the volume to capacity ratio. Second is total number of. The last is the total travel time vehicle hours during the peak 15-minute periods. First, the volume to capacity ratio V over C, we can get also from the VP equal to VP over C. VP over C is the volume to capacity ratio. The C is the two-way segment capacity. Normally in 300 and 2000 for the two directional segment and 1700 for a directional segment. The second is the VMT15 equal to 0.25 times V over PHF times LT. PHF is the peak hour factors, while the LT is the total length of the analysis segment in kilometer unit. Next is the VMT16 equal to V times LT. LT as shown in the just now. So we can now we proceed to the TT15. TT15 equal to VMT15 divided by ATS. We calculate use like the previous slide show to get the ATS first, then we can get by substitute it into the following equation, we can get the TT15. Now I'm going to discuss about the example 9.4, level of service and performance measure for two-lanes, two-directional highways. Use the data from and the result in the example 9.2 and 9.3 to determine the following. First is calculate the level of service. Second is the volume to capacity ratio. Third is VMT15, and VMT16 and TT15. For part A, we can see here the following the given data PTSF and is 82%. So we can see that, and the ATS is 61.2 km per hour. By the given table, we can get that the low level of service is at the grade E, and for the from the table 9.2, we can get that the level of service is grade D for the case 1 and case 2 following respectively. For part B and C, part B is just substitute the value of VP over C, then we can get the VC equal to 0.757, while the VMT15 we use the formula 0.25 times 1600 divided by 0.95 times 9.6. We can get the VMT15 equal to 4042 vehicle per kilometers. For part D and E, the VMT16, by substitute the value V times LT, we can get the value is 15,360 vehicles per kilometer. And for the total travel time during the peak 15-minute periods, PT15, we can use back the value of VMT15, 4,042 divided by 61.2. We can get it 66 vehicles per hour. Now I'm going to pass to my groupmate to continue our presentation.
Okay, directional segment. There are three categories of directional segment are considered. First is extended segment. Extended segment located in level or rolling terrain with a length of at least 2 miles. The second is specific upgrade or downgrade. The specific upgrade or downgrade located in mountainous terrain or with grade of at least 3% of segment length of at least 0.6 mile long. The number 3 is passing length. A passing length added within a section in level or rolling terrain or as a truck climbing length. Next. Okay, to calculating the value of PTSF for directional segment in level or rolling terrain, we can use the equation 9.12, and to calculate this PTSFD, we need PTSFD equal to BPTSFD plus F and P. So BPTSFD equal to 100 times 1 minus E power of AVD power of B. Next. So the PTSFD is percentile span following in the direction analyzed, and BTTSFD is base percentile span following in the directional analyzed, and FMP is adjustment of percentage of no passing zone in the analysis direction, and VD is passenger car equivalent flow rate for the peak 15-minute period in the analysis direction, PC per hour. And A and B is the coefficient based on the peak 15-minute passenger car equivalent to opposing flow rate V0. Next. So this is the table to find the FMP. Next. This is the table to get the coefficient A and B. Next. So I will to go through the example 9.5 to is computing the value of percent time spent following PTSF for the peak direction on a two-lane highway. So I will read the example. During the peak hour on a class 1 two-lane highway in a rolling terrain, volume northbound 1,200 vehicle per hour and the volume southbound 400 vehicle per hour. The PHF is 0.95 and there are 14% truck or buses and 4% RV. Length width 11 feet and shoulder width 4 feet. The roadway section is 5 miles in length and there are 20 access points per mile. There are 50% no passing zone and the base free flow speed is 60 miles per hour. So determine the percent time spent following in the peak direction of travel. Next. So for the step 1, we need to compute peak 15-minute hour hourly passenger car equivalent in the peak directional VD and in the opposite direction V0. So we try the value of VD is VD per PHF equal to, so we can get 1,263 vehicle per hour. So next we determine the FG and determine the ET and ER as previous like previous slide. So we compute HFV with this equation. So we get also 1.00. Next. So we compute VD. So VD is the equation is V per PHF times FG times FHV. So we get 1,263 PC per H. So we try value of to V0 is V0 per PHF equal to 400 per 0.95. So we get 421 vehicle per hour. And we compute again the FHV, so we get 0.935. So after that, we compute V0. So V0, we get 479 PC per hour. Next. For step 2, we compute base percent time spent following BTSF using equation 9.13. So this is the equation that in the previous slide. So we determine the value A and B from the table 9.12 by interpolation. Okay. So we calculate it BPTSFD equal to 84.7%. Next. So the step 3, we compute percent the time spent following PTSF using equation 9.12. Okay, so we're now using the table 9.11 to determine the FMP. So this is the you can get from the equation. So we calculate it BTSFD equal to BPTSFD plus FNP. So equal to 84.7 plus 11.5. So we get 96.2%. Next. I will pass to my friend to present.
Hello, my test. I'm going to talk about the value of ATS, average travel speed for directional segment in level or rolling terrain. So the equation given ATS is equal to FSS minus 0.0125 V plus V0 minus FMP. And the ATS is the average travel speed in the analysis direction of travel in unit kilometer per hour. And FMP is the adjustment for the percentage of no passing zones in the analysis direction from the table 9.13. And FSS is the free fall speed in the analysis direction. Next. And I'm going to go through the example 9.6 is about the ATS for the peak direction on a 2-lane highway. And step 1 is same thing like the example 9.3. We know that the FSS is equal to 85.3 km per hour. And now we are going to compute V. And from the table 9.7, and our V is more than 600, and it is rolling terrain, and we can know that our FG is 0.99, and our ET is 1.5, EL is 1.1, and also we can get from the table 9.8. And we substitute into the equation to find the FHV, and we can get it is 0.931, and substitute into the equation. V is 1,200, PHF is 0.95, FG is 0.99, FHV is 0.931, and we can get the value is 1,370 passengers car per hour. Next. And now we are going to compute V naught, and the same procedure to find V naught. First step is we find FG from the table 9.7, and we know that our V is 400, and from the table we can find the FG is 0.93, ET is 1.9, EL is 1.1 from table 9.8. So we can get FHV is equal to 0.884, and our V naught is equal to 512 passengers car per hour. And our V and V naught are less than total 1,700. The capacity of a one-way segment FMP is equal to 1.6 using the table 9.13 by interpolation, and we can get the ATS is equal to 85.3 minus 0.0125 times with 1,370 plus 152 minus 2.56. The 2.56 is the conversion of the FMP 1.6, because the table is showing the 1.6 is miles per hour, so we convert it into the kilometer per hour, so we can get from the 1.6 to 2.56. So total our ATS is 60 km per hour. Next.
Now we will be going discuss example 9.7. Use the data and result in example 9.5 and 9.6 to determine the following. Question A, level of service if the segment is class 1 or class 2 highway. If the segment is class 1, refer to table 9.1. Due to PTSF equals to 96.2% is larger than 80%, so it is LOS E. If segment is class 2, refer to table 9.2. PTSF is larger than 85%, so it is LOS E. Next. Question B, volume to capacity ratio using equation 9.8 equals to VP over C equals to 1,370 over 1,700. 1,700 is the capacity of one-way segment. Then we will get the answer of 0.81. Question C, total number of vehicle miles during the peak 15 minutes period BMT 15 using equation 9.9 equals to 0.25 times V times LT over PHF. By substitute the value, we will get the answer of 3,032 vehicle kilometer. Question D, total number of vehicle miles during the peak hour VMT 60 using equation 9.10 equals to VD times LT. We will get the answer of 11,520 vehicle kilometer. Question E. Total travel time during the peak 15-minute period TT15 using equation 9.11 equals to VMT 15 over ATSD. We will get the answer of 50.8 vehicle per hour. Thank you. Next. Okay, we will pass to the other member. Thank you.
So we are going to discuss the value of PTSF and ATS for directional segment of specific upgrade. Grade of 3% or more and at least 0.6 mile in length. Length of 0.25 miles or more and upgrade of 3% or more. Segment in mountainous terrain are to be analyzed as a specific upgrade. When grade vary within a section, a composite grade is computed as the total change in elevation divided by the total length, which is expressed as a percentage. The effect of heavy vehicles are determined based on the average segment grade and segment length. To calculate PTSF, first we must determine FG from table 9.14, ETER from table 9.15, FHV from equation. Then we determine the FHV using equation 9.4. PT and PR is the decimal portion of truck and RE is the traffic stream. ET and ER is the passenger car equivalent for trucks and RE respectively. Next. This is the table 9.5 to determine the ET and ER. Next. Table 9.14 and 9.15. 9.14 is to determine the grade adjustment factor. 9.15 is ETER for estimating percent time spent following on specific upgrade. Next. To calculate ATS, firstly, we also must determine FG from table 9.16, ETER using table 9.17 and 9.18. Then we determine FHV using equation 9.4. After that, using equation 9.3, we determine VD. Next, using equation 9.3 to determine V0. We should take note that when computing V0, the value used for FHV and PHF should apply to the opposing direction of travel. Then finally, we compute PTSF and ATS following procedure used for directional analysis as described for level and rolling terrain. Next. Table 9.16 to determine the grade adjustment factor on specific upgrade. Table 9.17 to determine E for estimating average travel speed on specific upgrade. Next. 9.18 to determine ER on specific upgrade. Next. To calculate the value of PTSF and ATS for directional segment on specific downgrade. The following has to be analyzed as a specific downgrade, which are downgrade of 3% or more and at least 0.6 mile in length. Downgrade segment in mountainous terrain, opposing direction of travel to a specific upgrade. For most downgrade FG equal to 1.0. For heavy vehicle at specific downgrade that are long and stiff, FHV is computed using equation 9.15, which is listed below. PTC is the decimal proportion of truck in the traffic stream that travel at cross speed on the analysis segment. ETC is the passenger car equivalent for truck in the traffic stream that travel at cross speed on the analysis segment. Next. Table 9.19 is the ETC for estimating the effect on average travel speed of truck that operate at cross speed on long steep downgrade. Next. Example 9.8 to compute the volume on directional segment for specific upgrade and downgrade. First, we determine the value of VD for specific upgrade. Determine FG using table 9.14, FHV table 9.15, then FHV using equation 9.4. After that, we use the value to compute VD using equation 9.3. And we get VD equal to 1,405 passenger car per hour. Next, we determine V0 for specific downgrade, FG on downgrade, then ETC using table 9.19, ET and ER using table 9.5, FHV using equation 9.4. After that, we substitute the value into equation 9.3 to determine V0 equal to 468 passenger car per hour. Next.
Calculating percent time spent following PTSF for directional statement. Hello, dengar tak?
Low volume. Hello. Sorry for some technical problem before. Wait a while for our group members to adjust it.
Hello,
Yes.
dengar tak?
Yes.
Calculating percent time spent following PTSF for directional segment when a passing lane has been added within an analysis section in level or rolling terrain. Briefly, the function of passing lane is to provide motorists to overtake slow vehicle. PTSF can be reduced in widening section. Greatest effect would result if passing lane were long an entire length, and the effect decrease as its length is reduced. Next. Figure 9.4 is a plain view of a passing lane, and figure 9.5 is the effect of passing lane as represented in operational analysis methodology, which is PTSFD versus position along highway in miles. This region, L1, LU is length of upstream passing lane. This length is determined by where the plane or actual passing lane should be placed to the beginning point. For region 2, LPL is planned lane length including tapers. This section experience sudden reduction of PTSF and it depends on directional flow rate VD as in table 9.20. For region 3, LDE is a downstream length. This region considered to be within effective length and can be determined from table 9.22. For region 4, it is remaining downstream region within segment and it's known as LD. This beyond the effective length of passing lane. The passing lane value PTSFD is equal to upstream section of LU. Next slide. Okay, the average value of PTSF for entire analysis segment with passing lane of PTSF PL is using this and the full downstream length is not reached because of the traffic signal or town interrupt the analysis section, then L is replaced by a shorter length LDE as shown in equation 9.17. Next.
Okay. For the next is calculating average travel speed ATS for directional segments when a passing lane has been added within an analysis section in level or rolling terrain. So below is figure 9.6 illustrate these changes in value of average travel speed ATS that occur within each of the 4 regions when a passing lane has been added. So below are the values for region 1. Next slide. Okay, for region 1 is average speed in the upstream region is ATST for length LU. Region 2, average travel speed in the passing lane increased by factor FPL provided in table 9.2. The values range from 1.08 to 1.11 depending on the directional flow rate VD. Region 3 is average travel speed within the downstream length decreases linearly from the value in region 2 to ASTTLDE equal to 1.7 mile, as shown is 9.22. Region 4 is average travel speed in the downstream region ESTD for length LD. To compute the average speed for the analysis section, it is first necessary to compute the individual travel time within region 1, 2, 3, and 4. The average travel speed is the total analysis length LT divided by the sum of the 4 travel times. So the derivation below produced equation 9.18. The value of ATSPL, which is the effect of the average travel speed in the analysis section as a result of adding a passing lane. Okay, next. We are going to see example 9.9, which is the last example for our presentation. So example 9.9, computing level of service for 2-lane directional highways with a passing lane. Use data and result for example 9.5 and 9.6 to determine the LOS if a passing lane is added. The length of the passing lane is 1 mile and is designed to begin 1 mile downstream for the beginning of a 6-mile analysis section. So from example 9.5 and 9.6, we can get PTSF equal to 96.2% and ATS is 37 mile. So for step 1, determine the length of each region. For region 1 is LU equal to 1 mile. Region 2, LPL equal to 1 mile. Region 3, for PTSF, LBE is equal to 3.6 mile. We can see from table 9.22. From example 9.5, the VD is 1263 PC per hour, so it is greater than 1000. So because of this, we choose PTSF LDE equal to 3.6 mile. So the FPL is 0.62. For ATS LDE, we refer from example 9.6, which is the VD is equal 1370 PC per hour, which is greater than 1000. So the ATS LDE is equal to 1.7 mile from table 9.22 also, and FPL is equal 1.11 from table 9.2. For region 4, PTS LD can be calculated with equation LD equal to LT minus LU plus LPL plus LDE. So we can get this answer. Then step 2, compute PTS FPL using equation 9.16. We just substitute the information that we have gathered before, and we get 79.14%. For step 3, we can compute the SPL using equation 9.18. Substitute also and we get 36.3 mile per hour. So with this answer, we refer to table 9.1, which is LOS criteria for 2-lane highways in class 1. So we can get the LOS is equal to E with a passing lane. Okay, next. Okay, calculating the average travel speed ATS for directional segment when a climbing lane has been added within an analysis section on an upgrade. So it warranted into 2 lanes highways when one of the following condition is met. First is directional flow rate on the upgrade 200 vehicle per hour. Second is directional flow rate for trucks on the upgrade 20 vehicle per hour. And when any of the following condition apply, Speed reduction for trucks is 10 miles per hour for a typical heavy truck. LOS is E or F on the grade. LOS on the upgrade is 2 or more level of service values higher than approach grade. Next. Computing the combined value of PTSF and ATS for contiguous. Directional analysis segment. Directional two-lane highway facility is composed of a series contiguous directional segments, each analysis separately as previously described. A combined value PTSF and ATS can be used to determine the overall LOS is computed by using equation 9.19 and 9.2. Okay, like below are the equation. So that's all from our group. Thank you.
Thank you very much. Terima kasih kepada kumpulan 7 for a very nice presentation. Dr. Su nak tambah ke kita nak continue terus?
I think kita continue dulu. Nanti kita take questions ke, kita buat summary ke, conclusion after that lah. Boleh?
Boleh. So but I think before that we take a 2 minutes break je.
Okay, no problem.
Sebab nak I think it's quite difficult juga ni nak digest all the terms FSS, PTSF, LU, LB, so on and so forth. So
it's quite dry juga. Tak ada gambar kan.
So kita sambung lagi 1 minit. Rehat sekejap. 1 minute rest.
Sure.
Okay, thank you, Doctor.
Thank you very much, Group 7.
Possibilities. Today, I will bring you guys around UKM. Let's go!
nampak ke doktor?
Tadi dah nampak, sekarang dah tak nampak. Okey. Nampak. Okey.
Okay, good morning everyone. Today we'll be presenting on the topic capacity and level of service for highway segment. So let's get into the topic. Next slide. Hello. As our previous group said, flow rate and capacity is the primary consideration in planning and designing of highway facility. The main objective is design or plan facility that will operate at flow rates below their optimum rate. While the capacity analysis involves quantitative evaluation of the capability of road section to carry traffic, the level operating performance changes with traffic density. So in this topic, we will learn about the procedure determining the level of service and other performance measure on uniform road segment on two-lane and multi-lane highway and freeways. This will lead us to plan a design and optimum roadway. Next.
The procedures developed for two-lane highway segments provide the basis to evaluate levels of services and capacity. For the highway segment, there are two levels of analysis, which are planning, application, and operational. Next slide. There are two classes of two-lane highways that are defined according to their functions. Class 1 functions as primary arterials, daily commuter routes, and links to other arterial highways. So motorists expect to travel at a high speed. For Class 2, serve as access to Class 1, scenic byways, or may be used by motorists for sightseeing. It is located in rugged terrain and motorists expect to travel at a low speeds than Class 1 routes. Next slide. At an operational level of analysis, level of service is determined based on existing or future traffic conditions and specific roadway characteristics. The highway capacity manual procedure is designed to analyze for two-way traffic for a specific direction or for a directional segment with a passing lane. At planning level of analysis, operational procedures are followed but with estimates, HCM default values and or local default values. Annual average traffic values are used to estimate directional design hour volume. Next slide. There are two measures used to describe the service quality of a two-lane highway. Percent time spent following another vehicle is the average percentage of travel time that vehicles must travel behind slower vehicles. Average travel speed is the mean speed where segment length is divided by average time for all vehicles to traverse the segment in both directions during a designated interval. Next, please. Capacity of a two-lane highway. For each direction of travel and it's nearly independent of the directional distribution of traffic are 1,700 passenger cars per hour. For extended segments, not exceed a combined total of 3,200 passenger cars per hour. And for short sections, may reach a capacity of 3,200 to 3,400 passenger cars per hour. Levels of services express the performance of highway at traffic volumes less than capacity. LOS for Class 1 highways based on PTSF and ATS, and LOS for Class 2 highways based on PTSF only. Next, please. LOS A is the highest quality of services where motorists are able to travel at their desired speed. For Class 1, ATS is 88 km per hour or greater. PTSF occur no more than 35% of the time. For Class 2, maximum PTSF is 40% of the time. Maximum service flow rate under base condition is 490 passenger cars per hour. LOSB is where if vehicles are to maintain desired speeds, the demand for passing other vehicles increases significantly. For Class 1, ATS are 80 to 88 km per hour. PTSF occur between 35 to 50% of the time. For Class 2, maximum PTSF is 40 to 55% of the time. Maximum service flow rate under the base condition is 780 passenger cars per hour. Next. LOSC is further increases inflow beyond the LOSB range. For Class 1, ATS are 72 to 80 km per hour. PTSF occur between 50 and 65% of the time. For Class 2, maximum PTSF is 50 to 70% of the time. Maximum service flow rate under base condition is 1,190 passengers cars per hour. LOSD is where flow is unstable and passing maneuver are difficult. For Class 1, ATF are 64 to 72 km per hour. PTSF occur between 65 and 80% of the time. For Class 2, maximum PTSF is 70 to 85% of the time. Maximum service flow rate under base condition is 1,830 passengers cars per hour. Next, please. LOSE is where passing have become virtually impossible. Operating conditions are unstable and are difficult to predict. For Class 1, ATS are 40 miles per hour or less. PTSF occur more than 80% of the time. For Class 2, maximum PTSF is greater than 85% of the time. Maximum service flow rate under base condition is 3,200 passengers cars per hour. And the last one, LOSF, is where traffic is congested with demand exceeding capacity. Volumes are lower than capacity and speeds are variable. Next. The procedures for determining the LOS of a two-lane highway are carried out separately for the following cases. First one is two-way segments located in level or rolling terrain. Grids are 1 to 2% and heavy vehicles maintain the same speed as passenger cars. And the second one is directional segments used to analyze extend directional segments. Specific upgrades or downgrades defined as two-lane highway located to mountainous terrain or with the grades that exceed 3% in the segments exceeding lengths 0.6 meter and passing lanes for relatively short uniform segments. Next.
Okay, two-way segments. The analysis of two-lane roads for two-way segment is usually performed on extended lengths when the segment length is at least 2 mi. The segment is located in level or rolling terrain. Definition of level and rolling terrain are as follows. Level terrain is a segment contain fleet grade of 2% or less. Heavy vehicles are able to maintain the same speed as passenger cars throughout the segment. And a rolling terrain is segment contain short or medium length grade of 4% or less. Heavy truck speeds are lower than passenger cars but are not at cruise speed. If the grade exceeds 4%, the two-way segment procedure cannot be used but must be analyzed using the specific grade procedure for directional segments. Okay, next. There is a formula used to calculating the value of PTSF for two segments. Okay, next. For example, determine the value of PTS for 9.6 km two-lane highway in rolling terrain. Traffic data are as follows. Volume 1,600 vehicle per hour. Two-way. Percent trucks is 14. Percent RVS is 4. Peak hour factor is 0.95. Percent directional split is 50-50. Percent not passing zone is 50. And for the solution, step 1, compute peak 5 minute hourly passenger car equivalent VP, which is we find the VG value at table 9.5 and ET and ER value from table 9.5, and we find the FHV value is 1 and VP is 1,684 per hour. Okay, next. Okay, for step 2 is compute base percent time spent following
BPTSF, which is the value is 77.2%, and step 3 is compute percent time spent following PTSF, which is the value is 82%. Okay.
Calculating the value of ATS for two-way segment. So the average travel speed ATS for a two-way segment is computed by the following formula. Next. The determination of free flow speed FFS can be completed in 3 ways. So the first way is if the field measurement at volume is below and upper the 200 passenger car per hour. Next. So second way is when the indirect estimation, which when field data are unavailable. And third way is the base free flow speed, BFFS, depends upon the local conditions regarding the desired speed of the drivers. So the estimation of BFFS is based on the knowledge of the area and the speeds on the similar facilities. Range of this BFFS is 72 km per hour, 72 to 142 km per hour. Next. So example of computing the value of average travel speed. So following the question, use data provided in example 9.2 to estimate the average travel speed. Assume that the base free flow speed BFFS is the posted speed of 60 miles per hour. The section length is 6 miles, length width is 11 feet, shoulder width is 4 feet, and there are 20 access points per mile. So step 1, we compute the free flow speed under the given conditions as the following formula. Next. Then this is the adjustment FLS from the table 9.1. This is how we got the 1.7 for FLS, and table 9.10, table 9.10 adjustment of FA. So this is how we got the access point density. Next. Step 2 is that we compute average travel speed using the equation of 9.5. So, like the following formula, we determine the FG following by the table 9.7. So, it's how we got the 0.99, and the FG, the V is we get from the 9.2 example, rolling terrain more than 1,200. Next. So this is how we got the ET, LRV, ER from the table 9.8. Next. And this is table 9.6, how we get FNP by interpolation to get the 0.8. Next. So calculating the other traffic performance measures for two-way. So there are volume to capacity ratio. So this is how we compute the volume to capacity ratio following the formula. Next. And second is the total number of vehicles miles traveled during the peak 50 minutes period. And the other additional measures is the total number of vehicle miles traveled during the peak 60 minutes period. And this is the total travel time vehicle kilometer during the peak 50-minute period. Next. So that's all.
For directional segment, there are 3 different types of directional segments to consider. One is a standard segment of at least 1.2 km in level or rolling terrain. 2 specific upgrades or downgrades for parts of at least 1 km in mountainous terrain or with slope of at least 3%. 3, a passing lane inserted into an area of flat or rolling terrain or as a truck ascending lane. Next. For calculating the value of of PTSF for directional segments in level or rolling terrain. The following formula is
Wait, did that appear?
The following formula is PTSFD equals to BPTSFD plus FNP. For BPTSF, we're going to use the formula 100 times 1 minus exponent to the power of AV to the power of B, where PTSF stands for percent time spent following in direction analyzed. BPTSF stands for base percent time spent following in the direction analyzed. FNP stands for adjustment for percentage of no passing zones in the analysis direction. VD stands for passenger car equivalent flow rate for the peak 15-minute period. A and B stands for coefficients based on peak 15-minute passenger car equivalent opposite flow rate. Next. So this is the table 9.11 to determine the opposite demand flow rate or FFS. Next. This is the continuation from table 9.11. This is table 9.12 to determine the coefficient of A and B. Next. Next. Okay. Example of calculation computing the value of PTSF for the peak direction on a two-lane highway. So I'm going to read the question. During the peak hour on a class 1 two-lane highway in rolling terrain, volumes northbound are 1,200 vehicle per hour and volume southbound are 400 vehicle per hour. The PHF is 0.95 and there are 40% trucks or buses and 4% RVs. Lane width are 11 feet and shoulder width are 4 feet. The roadway section is 5 miles in length and there are 20 access points per mile. There are 50% no passing zones and the base free flow speed is 60 miles per hour. Determine the PTSF in the peak direction of travel. So step 1, we're going to compute 50-minute hourly passenger car equivalent in the peak direction VD and opposite direction V note. So the trial value for VD, we're going to use the formula VD over PHF. So we got 1,263 vehicle per hour. To determine FG, we're going to use the table 9.4 as you can see from your right hand side. So we got the value for FG is 1.00. And to determine ET and ER, we're going to determine the value from table 9.5 from your right hand side also. We got the value for ET equals to 1.00 and volume for ER equals to 1.00. Next, we're going to compute FHB. So I got 1.00, so we use the formula given there. Next. Next, we're going to compute VD. So VD is equals to the V over PHF times FG times FHB. So we got 1,263 passenger car per hour. So try V note. We're going to use the formula V note over PHF. So we got the value 421 vehicle per hour. So to determine FG, we use the same table 9.5. So the value of FG is 0. To determine ET and ER, we're going to use the value from table 9.5. So ET equals to 1.5 and ER equals to 1.0. So to compute FHB, the same formula from the one we use. So we got the value for FHB equals to 0.0 0.935. And we're going to compute V naught. So V naught equals to V over PHF times FG times FHP. So the value is 479 passenger car per hour. So step 2, we're going to compute the BPTSF, base percent times span following. So we're going to use the formula 100 times 1 minus exponent to the power of AV to the power of B. So we're going to determine the values coefficient of A and B from table 9.12 by using interpolation. So for coefficient A, the value is negative 0.074 and B is negative 0.453. So we have the value for coefficient A and B. So we're going to substitute it into the formula to determine BPTSF. So we got 84.7%. So for the last step, we're going to compute PTSF percent times span following. So we're using the table 9.11 to determine F and P. So the value of F and P is 11.5. So we substitute the value to the formula to find PTSF D. So the value for PTSF D is 96.2%. Next.
Yeah, so now we're going to calculating the value of ATS for directional segment in level of rolling terrain. So as you can see, equation 9.14, ATS as average travel speed in the analysis direction of travel, FFST, free flow speed in the analysis direction, VD, passenger car equivalent flow rate for the peak 50-minute period in the analysis direction, V0 passenger car equivalent flow rate for the peak 50-minute period in the opposing direction of travel, and FMP, adjustment for the percentage of no passing zone in the analysis direction, which can be referred to table 9.13, this table. So for obtaining FMP, we need to have the no passing zone value, FFS value, and also V0 value. And then now we're going to compute the value of ATS for the peak direction on a two-lane highway. This is the given data from the previous example. So we're going to estimate the average travel speed ATS. We have two-lane highway in rolling terrain, volume, peak hour factor, percent truck, percent RV, percent zone, BFFS, lane width, shoulder width, access point per kilometer. For the first step, we're going to calculate the FFS, where we're going to use the equation 9.7. So to obtain the FLS and FA, we need to refer to table 9.9 and 9.10. This table. This table in feet, but my example in SI unit. So I'm just going to convert it. So as you can see, from this 4 feet, and then the shoulder width is 4 feet, and then the lane width is 11 feet. So we get 1.7 equivalent to 2.7 kilometer per hour. And then for the FA, for the mile, we got 20 access point per mile. So we got reduction in FFS is 5.0 mile per hour, equivalent to 8.0 kilometer per hour. So we sub the value in the FFS equation. We got 85.3 kilometer per hour. So next step, we're going to compute the ATS. But before that, we need to find the VD, which is passenger car equivalent flow rate for the peak 50-minute period in the analysis direction passenger car per hour. So we need to find the FG based on table 9.7 and also ETAR based on table 9.8. And then we got the value, we substitute in equation 9.4, which is FHV, that is adjustment factor to account for heavy vehicles in the traffic stream. So we got the value for VD is 1370 passenger car per hour. Next, we compute for V0, which is passenger car equivalent flow rate for the peak 50-minute period in the opposing direction of travel. So we find the FG in the table 9.7 and then ET and ER in table 9.8. And then we substitute again in equation 9.4. And then we got the value of V0, 512 passenger car per hour. And then for value FMP, we need to refer to the table 9.13. So since our FS is 85.3 km per hour, which is equivalent to 53.3 miles per hour, so we need to do few interpolation to obtain the FMP. So first we need to interpolate the FS in 55 miles per hour, so we get FMP as 1.702. Then secondly, we interpolate FFS for 50 miles per hour. Then we get the FMP 1.48. And the last interpolation to find the real FMP value. So we sub the value into the interpolation equation, and then we got 1.6 miles per hour, which equivalent to 2.56 km per hour. And then we sub all the value into the ATSD equation. Then we got the 60 km per hour for the ATSD.
Calculating the value of PTSF and ATSF for directional segment on specific upgrade. Any grades of 30% or more and at least 1 km in length must be analyzed as a specific downgrade. To calculate PTSF, first of all, we should determine the grade adjustment factor using table 9.14. Then the passenger car equivalent for truck and RV can be found using table 9.15. By using this equation shown here, we can compute the heavy vehicle factor. Next. These are two tables, which is table 9.14 and 9.15 that are used to calculate PTSF as I explained before. Next. To calculate ATS, the first step is to determine the grade adjustment factor using table 9.16. Then determine the passenger car equivalent for truck and RV. Compute heavy vehicle factor using equation 9.4 as the third step to calculate ATS. Then equation 9.3 should be used to determine the passenger car equivalent flow rate in analysis direction and opposite direction. Lastly, compute PTSF and ATSF following procedure for use for direction analysis as described for level and trolling retrain. Next. These are the three tables that we'll be using to calculate ATS. Next.
Okay, now we will look at the example of computing volumes on directional segment for specific upgrade and downgrade. So this is the example question. The question asks us to find the value of passenger car equivalent flow rate in the analysis direction and opposing travel direction, which denoted as VD and VO. These are the information given to solve the equation, as you can see on the screen. Next. Okay, firstly, we have to compute for VD and VO for PTF and VD for specific upgrade. We can find the value of FHF from the table 9.14 as showed before. So we have to look at the grade percentage and length of grade to find FG value. For the question, okay, for the FHV, where we use the table 9.15 and obtain the value of ET and ER, which is 1.8 and 1.0 for this question respectively. After that, we have to calculate for FHF using the equation 9.4 as shown here. And after that, we continued with calculating VD, substituting all the information into equation 9.4. Next. Next. Okay. Okay. After finding VD, we will proceed to compute for specific downgrades. As previously, we will start with finding FG, which is 1.0. Then we will find the value of ETC after the table 9.19 and find ET and ER as previously done again. Calculate for FHV by adding ETC value to the equation, and we will get the final answer of VO. That's all. Thank you. Next.
SF for directional segment when passing lane has been added. A passing lane is added to a two-lane highway and the percentage of time spent following can be reduced in the widened section. The passing lane are provided in a variety formats and they may be exclusively for a single direction of traffic or opposing traffic may be permitted as its use. Next. Okay, here are the analysis methodology. For Region 1, the PTSF in the immediate region preceding the passing lane of length LU and the length of Region 1 is determined by deciding where the planned or actual passing lane should be placed relative to the beginning point of the analysis segment. For Region 2, the passing lane of length LPL is constructed or planned length shown in the slide. The extent of reduction of FPL in PTSF range between 0.58 and 0.62 depending on the directional flow rate VD. The optimal length of region 2 is determined from the table 9.21 and ranges from 0.50 to 2 miles depending on the directional flow rate as well. For region 3, the region immediately downstream benefit from the effect of passing lane as the PTSF increases to its original value. So this region is considered to be within the effective length and it is assumed that the value of PTSF increases. For region 4, this is the remaining downstream region and this section is beyond the effective length of the passing lane and the value of PTSFD is equal to the upstream section of length LU. Next slide. This is what I've been explained just now. Okay, next. Next. This is for ATS analysis segment. For region 1, the average travel speed in the upstream region is ATSD for length LU. And for region 2, the average travel speed in the passing lane increased by a factor FPL, also provided in table 9.20. And the value range from 1.08 to 1.11 and it is also depending on the directional flow rate VD. For region 3, the average travel speed in the downstream length decreased from value in region 2 to ATS. For region 4, the average speed for the analysis section and it is necessary to compute that the individual travel time within the region T1, T2, T3 and T4. The average travel speed is the total analysis of LT and divided by the sum of the 4 travel times. The derivation which is the effect of the average travel speed in the analysis section as a result of adding passing lane. Okay. Okay, example. use data and result, for example, 9.5 and 9.6 to determine the level of service if a passing lane is added. The length of the passing lane is 1.6 km and is designed to begin 1.6 km downstream from the beginning of a 9.6 km analysis section. From example 9.5 and 9.6, we get PTSF equals to 96.2% and ATS equals to 60 km per hour. Next. Okay, for step 1, determine the length of each region. For region 1, we got 1.6 km. Region 2, we got 1.6 km. Region 3, we got 5.8 km for PTSL and 2 km for ATS. Region 4, we got PTSL 0.6 km and ATS 0.5 km. Next. Step 2 is compute PTSF using equation 9.16. The equation as shown below, and we got 29.06%. Step 3, compute ATS using equation 9.18, equation as below, and we got 94.4 km per hour. Next. Step 4 is determine level of service. So we can conclude the example as LOSA with a passing lane.
Okay, for calculating ATS for directional segment climbing lane aided, climbing lanes are warranted on 2 lanes highway when one of the following conditions are met. Directional flow rate on the upgrade is more than 200 vehicles per hour. Directional flow rate for trucks on the upgrade is more than 20 vehicles per hour. Speed reduction for truck is 16 km per hour for a typical heavy truck. LOS is E or F on the grid. LOS on the upgrade is 2 or more levels of services value higher than the approach grade. In calculating ATS for climbing lane, the procedural steps are the same as described for computing ATS in rolling train by using this formula. But the difference are just when to determine the grade adjustment factor FG and the heavy vehicle factor FHV. This value for climbing lane can be obtained in table 9.14 and 9.15. Climbing lane will be analyzed as a passing lane if it's not long or steep enough to analyze as specific upgrade. Next. Okay, for conclusion, capacity for a two-way lane is 1,700 passenger cars per hour. This capacity is for both direction of travel and it is nearly independent of the directional distribution of traffic. The capacity of two lanes will not exceed the total combined of 3,200 passenger car per hour for extend segment. For example, tunnel and bridge, it will not reach capacity of 3,200 to 3,400. Level of service expresses the performance of a highway at traffic volume than capacity. The level of service is a measure on how well the facility is operating. That's all from us. Thank you.
Okay, terima kasih kepada Kepala 8 for nice presentation. Dr. Su nak tambah ke?
Thank you to both groups. Nice presentation. Saya tak ada nak tambah apa sangat lah. It just I want to summarize that apa yang kita belajar hari ni kan. Boleh ya Doktor? So
Boleh.
basically kita ada 3 classes of two lanes highway lah. Okay, so kita hari ni kita discuss about the level of service. Okay, the level of service of the highways. Okay, kita ada yang tadi tu A sampai F kan. So always kita punya we always wanted that level of service yang terbaik. Yang mana tadi? A, is it? Kan? So tapi itu untuk highway. Macam mana pula untuk jalan yang tadilah 2 lane kan? 2 lane ni macam yang satu pergi satu balik kan. So kalau untuk yang itu kita ada apa nama tu? Sekejap. We have 3 classes, okay, of 2 lane highways yang 2 lane macam tu. So kita ada class 1, class 2, class 3 kan. So this service measure, kita ada 3 karakteristik untuk measure the service. Alright, so by tadilah ATS, PTSF dengan PFS tu kan. So what happen kalau kita, tapi maknanya macam bila dua tu kita akan ada apa nama tu yang tadi tu lah, time spent following kan. So kita tak boleh potong memintas kan. So that's why untuk to reduce this following time, lepas tu untuk dapatkan apa nama tu higher level of service, kita introduce passing lane tadi. So passing lane ni and then there are 2 condition of kita punya jalan kan. Satu yang on level, kalau level ni kita boleh allow memotong pada apa nama tu lane yang sebelah tu kan. So you had already discuss berapa panjang passing lane yang allowable untuk memotong yang apa kalau guna lane yang sebelah, ataupun kalau untuk rolling terrain, maknanya yang berbukit tu, if you notice that kita introduce climbing lane. So kalau macam nak naik Camera Highlands tu kan, lama tak pergi kan. So kalau turun tu satu aja kan. So kalau naik tu, if you notice kita ada dua lane. So yang satu tu yang sebelah satu lagi tu kita panggil climbing lane. So these are also passing lane. Okay, so supaya kita tak perlu follow kereta depan, kenderaan depan yang slow tu, so kita boleh passing. So you also had apa nama tu discuss on all this. Okay, yang tadi tu kalau the effect of this passing lane on apa nama tu PTSF apa semua tu, and then this the effect of this passing lane on the travel speed, and also I hope you understand your discussion for today. So kalau macam misal kata you have any question, feel free to ask Dr. IZZI, or you can ask me as well. I think itu je lah, Doktor.
Okay, terima kasih Dr. Su. Saya punya nota ni lain sikit daripada kamu punya tu. Mungkin I think Dr. Su pun guna buku lain kan?
Yes, kita punya buku yang apa US punya kita pakai MAL kan. So dia punya formula tu ada sikit, ada yang macam yang dia orang guna ni dah convert to matrix terus. So that's why dia punya conversion number tu lain daripada kita punya kan. Tapi kalau you guna yang US ni pun boleh juga kot. Just you have to convert the MAL tu nanti.
Okay.
Sama kan kita punya nota, Doktor?
Itulah saya tengok tadi pun pening-pening. Tengok lain sikit dia punya presentation. But still okay. Terima kasih Dr. Su. Saya pun tak ada apalah, just apa ni. Actually to wrap up apa yang kita belajar ni adalah sebenarnya tentang kita nak tahu level of service lah. Level of service, LOS untuk apa ni highway, untuk 2 lane highway ataupun yang lebih lah. And then cuma just to apa ni flashback apa ni, bila tadi kamu dah cerita tentang apa terrain lah, terrain kan. Terrain dia punya, so basically kalau kita refer dalam CKR specification, kita ada 3 lah, sebenarnya sama je. Tiga terrain, 3 classification. Yang pertama kita panggil sebagai flat terrain. Flat terrain di mana dia punya grades tu adalah less than 3%. Sama yang macam kamu kita tadi lah, 1 dengan 2% tadi. And then the second one kita bercakap tentang rolling terrain, yang mana dia punya gradient adalah di antara 3 hingga 24%. Less than 25% lah. Between more than 3 but less than 25%. Itu untuk apa ni rolling terrain. And then satu lagi yang apa ni kamu cakap, satu lagi yang kita tak cover adalah tentang apa ni mountainous atau kawasan berbukit yang mana dia punya gradient adalah lebih daripada 25%. Itu kalau kamu rujuk dalam JKL specification adalah, cuma dalam yang ni dia tak cover untuk apa, untuk mountainous, dia cover just untuk apa ni flat dengan rolling terrain. So at least bila kita cerita tentang rolling terrain, kamu tahulah dia punya gradient adalah between apa ni 3 to 24%. Kalau yang apa tu, yang flat adalah di antara apa ni 1 dengan 2 lah. Okay, so basically apa yang kamu cerita tadi adalah based on apa ni highway capacity manual lah, analysis apa ni highway capacity manual 2010. Sebenarnya kita ada two types of analysis. Yang pertama adalah based on apa ni based on highway capacity manual. Ada satu lagi based on macro simulation, iaitu ataupun satu lagi modeling lah. And then apa yang kita bincangkan tadi semua dengan graf tadi, pada graf apa macam graf apa tadi FFS, free flow speed dengan ATS tadi kan. Itu semua sebenarnya adalah based on, dia itu adalah empirical lah, based on experience, based on previous studies done by a group of researchers daripada US lah. Itu dia, sebab tu bila kita tengok dalam graf tu dia tak ada value, just dia tunjukkan trend saja. So yang value tu adalah daripada apa ni, daripada table lah. So basically kalau kita nak implement dekat Malaysia pun, what we have to do is kita kena sebenarnya kita kena redo lah. Itu memang condition might be true for the US condition, but kalau kita nak implement dekat Malaysia, maybe we need some modification lah. Kadang-kadang kita tak boleh nak ambil just copy and paste and then you implement in for Malaysian condition. What we have to do is we can copy, but we have to do some modification, and after that we can implement to our condition. So ya pun yang lain tu banyak term lah, nanti kita nak kena faham lah. But at the end of the day, macam yang Dr. Su bagi tahu tadi, kita kalau boleh kita nak ada yang free flow speed lah. Free flow speed yang kamu bincang tadi, kita ada 6 level of service. Kita ada from A until F lah. A is the best, and then the worst is F. Selalunya apa yang kita seboleh-bolehnya, biasanya jarang kalau kita nak dapat jalan apa ni level of service LOS A dengan B ni, kecuali macam keadaan sekarang lah kan, dengan MCO ni mungkin kita boleh tengoklah jalan tu tak ada kenderaan on the road kan. Tetapi biasanya kalau dalam kita punya design, seboleh-bolehnya kita nak dalam level of service C lah. Betul lah tu Su? C kan?
Ya, at least.
At least C lah. So kalau maksudnya bila kita buat apa ni traffic analysis, kalau kita punya jalan tu ataupun highway tu dah level of service D ataupun E, we have to do something lah. Either you have to construct apa ni, kita kena buat apa ni road widening project, instead of 2 lanes maybe kita kena increase apa tu kepada 4 lanes highway ke, ataupun we are going to provide a new road ke dekat situ kan. Itu kita kena tengok lah. Itu yang biasalah. So as a rule of thumb, kita nak dia punya level of service dalam lebih kurang C lah. C, D I think masih okey lagi, tapi dah started to apa ni, jalan tu congest lah. Dia dah makin sibuk lah. And then sebab tu dia tak boleh nak gerak secara free flow speed. Okey, saya rasa itu sajalah saya punya komen. Satu lagi saya ada bagi satu video lah. Itu pun sebenarnya saya ambil daripada YouTube juga. So kamu boleh cari pun dalam YouTube. So saya dah share dalam WhatsApp group. Nanti boleh tengok lah. Actually the same what kita belajar hari ini. Benda yang sama jugalah. Level of service untuk 2 lanes highway. Okey, so saya ingat itu saja. Nanti kita jumpa lagi pada hari Jumaat ya. Pada pukul 10 untuk webinar nanti. Ada soalan ke? So semua diam ni tanda setuju lah.
Tak ada, Doktor.
Okey. So tak apalah, kalau ada apa-apa boleh tanya kemudian ke apa ke semua, tak ada masalah lah. So you can either WhatsApp me ke email ke apa kan, tak ada masalah. Boleh tanya Dr. Su pun boleh. Okey, so terima kasih semua. Nanti kita jumpa lagi hari Jumaat pada pukul 10 pagi ya.
InsyaAllah.
Terima kasih semua. Okey.
Okey, terima kasih.
Terima kasih, Doktor. Terima kasih, Doktor.
Thank you, Doktor.
Thank you, Doktor.